In this video, I'm going to discuss the general structure of Kuibit. Kuibit has three groups of modules. First one is utilities. Utilities are modules for specific tasks. For example, for plotting, unit conversion, or adding common arguments, or making videos, or doing specific calculations like with gravitational waves. For instance, computing antenna pattern, converted between luminous distance or redshift, or all these kind of things. These are somehow standalone. They don't necessarily require all the other structure that is in Kuibit. And these are the most easy to understand. They just accomplish specific tasks. Next, we have objects. Objects are high-level representation of data. For instance, a time series has two sets of data. We have the time and we have the data. But we want to deal with these two pieces of data in a coherent way. We don't want to consider them just simply lists or arrays. So these objects are high-level representation of all these intuitive concepts for us physicists, like time series, grid data, so that we can think more clearly, since we don't have to deal with all the messy of keeping track of the details of like keeping time synced with the data, all this stuff. And we can do high-level operations on these objects, for instance, adding time series or subtracting, all this kind of stuff. So we have objects for time series, frequency series, grid series. We have objects for grid data, so hierarchical grid data, uniform grid data, or for like grids themselves. Next, we have the readers. Readers are modules that are responsible for reading information and presenting the user with objects. So let me give you an example. This will hopefully be clear with an example. So first, we import the most important reader of all of them. This is SimDir from Kuibit. I'm here in an IPython notebook. From Kuibit, SimDir, import SimDir. This is the most important reader of all of them. And what SimDir does, it organizes all the files in your simulation directory. In this case, what I have here is a series of files, all sorts of files. I have time report, and we have like 3D data, we have 2D data, we have horizon data, we have ASCII files. So what we do is simply read this directory. Then we can print SimDir. And what's happening here is that SimDir has scanned all the files and found all the content. So for example, we have gravitational wave data, we have time series, we have horizon data, we have 3D data. So this is the first and most important reader. Next, we have readers which are specialized for specific kind of data. For instance, let's consider grid functions. What we do is we define a grid function, or we can actually have a look at all the readers. So for example, we have electromagnetic waves with psi2, we have gravitational waves, we have horizons. In this case, we're going to focus on grid functions. So we're going to use GridFunctions or GF. And we can print all these readers to see what's inside. So in this case, we have 3D data, 2D data. And what the first level, so this GF does, is it scans takes information from SimDir and organizes depending on the dimension. So we have XYZ, XY, and so on. And this is called a GridFunctionDir. This dir means that it takes information from SimDir. But next, what we have another level of readers. So what we do is we, for instance, focus on the XY plane. So we have GF and we focus on the XY. So these are readers only for the XY dimension. So we have all these variables and the XY dimension. So, and if we print what type is this GF XY, we have all grid functions, which means that this reader contains all the grid functions. So this reader indexes all your data depending on grid function. So if we want to access, for instance, row, what we do is we can use, for instance, the bracket operator, or alternatively, we can use the .fields.ob. These are completely equivalent. And what is row? Row is yet another reader. This is a OneGridFunction. And what it does, OneGridFunction readers, what they do is they organize depending on the iteration. What we can do is, for instance, print the available iterations. In this case, there is only 3 iterations. It's a very small snapshot of data. And finally, what we can do is we can actually read this data by providing the iteration. So here we actually have data. So if I look at the type of this object, what we have is a hierarchical grid data. So this is one of the objects that we had before, and we can do a lot of stuff with these objects. For example, we can consider and ask what is the time, probably. No. In this case, it's not defined, is it? We can do all this stuff. There's a billion functions, take partial derivative. How many course levels we have? 0. Okay, so probably this was an interesting data set. It's important to be familiar with all these readers so that one doesn't get confused with the structure. And it's often convenient to ask for the type of objects to know where you are at. And we can do the same for other readers. So the structure is always this, that we have SimDir and we have additional levels. So for example, for time series, we have time series. And if we can once again print to see what we have. And in this case, what we do is we index depending on the reduction. So for example, we can compute the maximum, and again, this is all with the maximum. And this will be all scalars because it's indexing specific scalars in this case. We can once again use the fields or the bracket operator to get the specific grid function, which in this case is the time series. We assign this time series. What we have is again a lot of useful functions. And what we can do is we can do things like this will be again a time series. But I will discuss these in more detail in future videos. What I want to stress in this video is the general structure of Kuibit as a library: utilities, objects, readers. Utilities are somehow standalone. Objects are the high-level representation that you are going to deal with for most of the time. And readers is this hierarchical structure that essentially it's designed to present you with specific objects: time series, hierarchical grid data, and so on.